Section 4.3 Elimination, Adding or Subtracting Method. Step 1. Line the equations up so the variables are on the left side of the equal sign and the constant term is on the right side. Step 2. The goal is to add the equations vertically so one variable will drop out. A variable drops out when each coefficient is the same and opposite in sign for a particular variable. You may have to multiply one or both equations for this to happen. Add the equations vertically. Step 3. If the variables drop out, the lines are parallel or the same line, and you can look back on the substitution method for those two conditions on step 3. And if you get a solution, put that number in either equation and solve for the opposite variable. So let's give one of these a try. X plus y equals 7. X minus y equals 11. So here the y's have the same coefficient. On the top equation the coefficient is a 1. On the bottom equation the coefficient is a minus 1. So when I add these equations vertically, x plus x is 2x. A y minus a y are none. 7 plus 11 is 18. Divide by 2, I get x equals a 9. So this has a solution. I'm going to put this into the first equation. The first equation says x plus y equals 7, but now x is a 9, so 9 plus y equals 7. Subtract 9, and I get y is a minus 2. So the solution to the system, x is a 9, y is a minus 2. Let's try another one. X plus 3y equals 29, and minus x plus 2y equals 11. Again, my x's this time are opposite in sign and the same coefficient. So when I add x, take away x, the x's drop out. 3 plus 2 on the y's is 5y. 29 and 11 is going to be 40. Divide by 5, y equals 8. I'm going to take that and plug it into one of the equations. It does not matter which one. So if I do it in the first one, x plus 3y is 29. So x plus 3 times 8 is a 29. X plus 24 is 29. Subtract 24. And I get x is a 5. So the ordered pair solution is 5, 8. Let's try one that I have to manipulate. 3x plus y equals minus 3. 4x plus y equals minus 4. Here, even though the y's both have a 1, they're both positive. So if I add these up, I'm going to get 2y. It's not going to make a 0y. So I'm going to multiply the top equation by a negative 1. So I'll switch the sign on that top y. So minus 3x minus y equals a positive 3. Notice the minus 1 was distributed over every single term. Rewrite the bottom equation. 4x plus y equals minus 4. Now when I add them, I get minus 3x plus a 4x is a positive x. My y's make a 0, minus y plus y equals 3 take away 4 is a minus 1. So x is a minus 1. I'm going to take that and put it back into the second equation. 4 times a minus 1 plus y equals minus 4. Minus 4 plus y equals minus 4. Add 4 to both sides. Looks like I'm getting a 0 for y. So the solution is minus 1, 0. Let's try one that doesn't quite work. 5x plus 8y equals minus 10, and 5x plus 8y equals 5. Again, if I add these equations, I'm making a 10x and a 16y. I'm not making a 0 on either of them. So if I multiply the top equation by minus 1 to switch one of the signs, again, everything has to get multiplied so it's distributed over all three terms. minus 5x minus 8y equals a positive 10. Rewrite the second equation, 5x plus 8y equals 5. Now when I add, I make a 0 on my x's, I make a 0 on my y's, but I made a 15 on the end. So I have 0 equals 15. These numbers do not equal. These are parallel lines. No solution. So here both variables completely dropped out. Let's try one more. 4x minus 3y equals 2 minus 8x plus 6y equals minus 4. Here, if I add my x's, I make a minus 4 on the x's. If I add my y's, I make a 3y. On the y's, I'm not making a 0. If I concentrate on my x's just randomly, if I want the x's to drop out, I have to make this 4x on the top equation a positive 8. So in order to do that, I multiply everything by a 2. So I have 8x minus 6y equals 4. Rewrite the second equation, minus 8x plus 6y equals minus 4. Now when I add the equations, everything drops out. I don't have any more variables, and even my numbers on the right side made a 0, and 0 does equal 0. So the solution to this is they are the same line, infinite solutions.